This is the second lesson of the whole Spark series. First, let's review some basic concept of Spark. Spark is a fast general-purpose engine for large-scale data processing. It is written in Scala, Java, Python, and R. And Scala is a functional programming language, which runs in JVM, so that we need to install the JDKs first before we begin to install Spark. And we are using the Spark shell for interactive programming. We can use Python, which is PySpark, or Scala programming language. You can issue the Spark shell to use Scala language. And we have already introduced demonstrate the word count calculation based on a basic text file. So we have using the Python programming language. So we have the first impression. And today we're going to deep dive to do some more complicated based on some data set we have already provided. Okay, let's get started using our own data set. First, we're going to issue the PySpark, which is the interactive programming interface for the Python on Spark. And then we're going to see the data set. The first one will be log file. We have some A code with integers, which stand for the article IDs, which we will talk about in detail later. And we also have IP addresses. And those two fields are the ones we are going to use in the later demonstrations. And the second one will be the list, which will be a dictionary for the article IDs and the article name. So we can look up this file to find what the article ID stands for. And those files is located in the local file system in the Linux. And we're going to load it into Spark. First, we're going to give variables and using the Spark context text file method to load the file from local file system. The first one will be the log file. And we can take two lines. So show is actually for the data frame. The web log is actually our RDDs. So it returns the error message that RDD object have no attribute to show. So we can see those two lines shows that we have already loaded the file successfully. We can use some method to see the variable web logs. We're using the filter to show all of the lines contains the A code, which is the article ID. So we can see there are more than 46,000 lines contains the A code strings. And the total lines of the log file is 61,000. So the type of web logs is actually the RDB, which is the resilient distributed data set we have already introduced in the last class. And we're going to filter those to extract those lines contains the A code. We are using the lambda expressions, which is the anonymous functions, which is some expressions for functional programming. We will talk about in later Python programming language. So we create new RDDs called weblogs filter. And so we can see it is another type of RDD called pipeline RDDs. So we're going to create another variables to hold the result from the count method belongs to RDD. So the count method is actually returns integer. And we can see there's different type of the functions belongs to RDD, which is filter, some method like filter and map. It turns one RDD to another. And some method like count, like take, it turns the RDD to a value. So there's different kinds of RDD. So we can see the SC is actually stands for Spark context, which is the one we must need when we start a Spark applications based on RDD. And now we are going to test what's the difference between the two kinds of method or functions belongs to RDD. Now we are input some file which is actually not exist in the file system, so no such file or directories. And we are going to load this file to give it to our RDDs. So we can see there's a no arrow returns. And we do a filter like we did just now. So also to give some filter informations in each lines. And we gave it to another RDD. So this kind of method calls transformations. So we type is actually a pipeline RDD. And it also does not return any error message, but when we to use another method of functions like count, so it returns how many lines belongs to this file, so it returns some error messages, shows input path does not exist. So we can see it is lazy for transformations. It means it did nothing until we issues the count or take, those we call actions method. We can actually find those informations in the paper we have shown in the last class. We can see that transformations are lazy operations that defines a new RDD, while actions launch a computation to return a value to a program or write data to external storage. So some operations like filter and map, flat map, they are transformations, and some operations like count, take, they are actions because they returns a value, or some of them are integers and some of them are strings. So this is the two kinds of operations for RDD. One is lazy, the other is immediate executions. First, let me introduce what we are going to do. We have two dataset 1 and dataset 2. This set1 is actually a log file which contains all the page view of each user. When user came to your website and click some pages, and it will left with trials, which is we call clickstream data. So it contains all the articles the user visited. And the AC code is stands for a real article, which we can find in the dataset 2. So AC code 1 is stands for one long article name, so we cannot use them in the real log data. It would be very large. So we usually use the article code stand for each articles. So what we're going to do is to join those two data sets and to find which articles is the most famous one. And we can find some relatives between the IP address and the article name. So that's what we are going to do. Let's issue PySpark first. And SC stands for Spark Context, which already have created when we issued the PySpark. And we are going to load the dataset1, which is the log file. We can actually using the type to complete the whole path. Take 2 lines to see if we have successfully loaded the data. First, what we're going to do is to filter those lines with the get and article ID. So which means those lines that the user is actually visiting the articles. And we have dropped the lines without visiting those with the AC code strings in it. So we can see now all of the lines after filter contains the AC code, which is the article ID. Now we are going to extract the AC code from those lines. So that we need regular expressions. So we import a library from Python called RE. That stands for the regular expressions. And we define a function called getACCode, which you give it a string, it will return the actually AC code. So it will return some strings applied to AC code with some integers, so which is the article ID. That's the data that's the string we want. So this is a simple functions with one line. And then we are going to use the anonymous functions to use the get AC code for each line. So the first thing we need to do is also to filter the AC line to get all of the lines contains the AC code. And then we are going to apply the get AC code, the functions we have just defined, to each line of after the filter. else then for each line, and we're using those functions to return the AC code. And the second part we want is the IP address. So we can use the blank for the separators and to fetch the second field, which is using this 1 and 0 for the first field and 1 for the second. So we take 3. So that's actually what we want. Okay, so we can see we use one actions called take, which means it will return some lines from the result. And we're using the count to count how many lines contains the AC code. We're using the distinct to see if there is some duplicate lines. So there's not, so we do not need count and distinct. We just delete those two methods and give this result to a new variables. So we can think about what type of these variables. We can use it using type to verify that it's actually a pipeline RDDs. That because the filter and map, they're all transformations. Transformation means they transform one RDD to another. So next we're going to load another this set, which is the dictionary for lookup. So the first thing we need is to create one RDD. So the function we use is the sc, which is spark context dot text file, which means we are going to load a text file into RDD. We can see from the source file the two parts actually separated by column. So the first thing we are going to do is to using the separator column to separate the two parts. So the split using column. The first part and the second part. We gave it to another variables, so it is actually RDD because map is a transformation. We can take two lines to see if we have successfully to separate those two parts. We have already loaded the two data set, and the next thing to do is to join these two data set with the article ID column, so which we can get the IP address and the real article name. So we can do a lot from those two informations. So we are going to do a join. So the first data set will be the AC code request. We define variables, maybe not, because we want to see the result, not. So we directly write down the AC request, join the AC list, which is the dictionary, the data set 2 in our chart from the beginning of the video, and take two columns, two lines, so we can see the article ID and IP address and the article name, which we do not. The column IDs, the article IDs is the information we do not want anymore. So we want only the IP address and the article name. So we try to figure out how to drop the article ID. So we are going to use a map, because map can let us to select different columns. So we are using map and lambda. The whole lines, L stands for the whole lines. And the article code will be the first part. And the IP address and the article name will be the second part. So we just want the IP address will be the first part of the second part. So it is a kind of messy. So, and the article name is the second part of the whole data set. So we take 3 lines. So that's what we want. We can see the IP address is actually have watched 3 articles, more than 3 articles. So we want to do a group by, which means that we can actually see how many articles that each IP address have read. So we can see from the result, the first part of the result will be the IP address, and the second part is iterable variables. So we cannot actually see the real article name. So we're going to use a loop. The IP address stands for the first part, and the titles will be take part in the will be replaced the second part of the iterable variables. So we print the IP address, which will be a string, and we give it a new line, so that will be easy to see. And there is another loop for getting each article names from the iterable variables. So give a tag from the beginning. It will because we cannot iterable in a we add because this is a method. So that's the real result we're going to see. We can see that each IP address, how many articles that each IP address have visited. So this is what we we are using the RDDs for the data analysis. We're going to use data frame to do the same thing. We have already introduced that. There is important components of Spark, which is called Spark Circle. And the other three are Spark Streaming and GraphicX and Machine Learning Library. And Spark Circle is for the relational data processing in Spark. And it is the primary representations of the data in Spark. And data frames represent structured data in the tabular form. And data frames model data similar to tables in the RDBMS. And it consists of a collection of loosely typed row objects. Rows are organized into columns described by a schema. And why we need Spark Circle is that we can see from this paper is introduced why we need a Spark Circle in the Apache Spark. And that is because the popularity of relational data system, which is stand for the RDBMS, is the relational database, and it is insufficient for many big data applications. First, users want to perform ETLs from various data sources, might be semi or unstructured data. So that's why we need custom code. And second, users want to perform some machine learning and graphic processing, and the circle statement are not good at those algorithms. So that's why we need custom code like Spark platform. But there is a gap. We already have the ability to deal with the semi or unstructured data using Spark. And also we have the machine learning libraries to deal with the graphic and machine learning processing. But how about the structured data? So the Spark Circle is for bridge the gap between the two methods, which is the two methods stand for the relational and procedures. So the relational means using the circle statement to deal with data, and procedures is using the customer code. And Spark Circle bridge the gap. We are using data frame APIs to deal with the structured data. Let's take a look at this chart. It shows that I already highlight that just now we are using the RDD APIs to deal with the data we have loaded from the file system. Now we are going to do the different thing. That we are using the data frame APIs to load the same data and to deal with those data using some circle-like a method to see how it improved the performance. Okay, let's get started. Okay, first we still issue the PySpark, which is the interactive programming interface. We can see there is already a Spark session started, which is used in Spark, a data frame API. It's different from the Spark context. So Spark context is actually for RDD, and Spark session is for the data frame. And we using the weblog data frame and using the Spark .read text file from the local file system. We can directly load this data from the directory. If you do not want to see the warnings, you can set the log level. SC set the log level to error, so only the error messages will return into the console. It only affects in this session. So weblog, we can show 2 lines, so we can see it is a tabular, just with 1 column called value. And we are going to separate those columns belongs to this line. So the separator will be, the first separator you can think about is the blank, but we cannot do that because some information will be separated when you are using blank, so it is not fit in these circumstances. So we are going to use some split and regular expressions method in Spark circle functions. So it will be the extract we are going to use the regular expressions to separate, to extract 3 columns from the whole line. And we can see that I will not go into the detail of the regular expression. You can take the code for reference. So now we can see there's IP address, timestamp, and the request in the table. And we can see some blank in the request column. So the next thing we are going to do is to load all of the result into a new data frame and to drop those requests with the blank values in it. So we remove the show because it like the action of a data frame. It will return a value. So we can do a type of the new data frame. So it is a data frame. And next thing we are going to do is to remove all of the lines with blank in the request column. We're using the filter method and use R-like, which with the regular expressions contains a code with some integers. So we can see it returns all of the lines with the AC code in it. So we can just give this whole result into a new data frame called filter. Now we have one data frame with the information we want, IP address and the request. We can remove the timestamp and just leave the IP address and the request. Okay, we're done with the first data set. Let's go to load the second dataset. And it's AC list. First, we also load it as RDD, and we transform this RDD into a data frame. So SC stands for Spark Context, and it has a method text file to load plain text from a local file system or HDFS. We import some packages, which is to transform the RDDs into data frame, which contains in the PySpark and circle row. The first thing we're going to do is separate the two parts, which is the article ID and article name, using the separated column. And we gave it into a new RDD called AC list 1. And we can, using the row method, to give each column a metadata, so which stands for the column name. So L stands for the whole line, and the row means this is for the data frame. So article ID equals to the first part of this RDD, and the article name is the second part of this RDD. So we can see this RDDs behave like this. And we are going to give these RDDs to a new variable, which is also RDD. We are going to use this RDD to create a new data frame. Spark dot create data frame from a RDD. So we type, it will be a data frame. Okay, now we're going to show two lines of this dataset. Article name, article ID, and name. Next, we are going to join those two datasets. This is the first dataset. We're going to extract two columns, which is IP address and the request. We gave it to a new data frame. Without using the show. So we are going to use the rename the column, because the request in the first dataset and there's an article ID in the second set. They are the same thing but with a different column name. So we renamed the request into the article ID. It will convenient for join. So we select two columns from this set. This will be the date frame 1, and this is the date frame 2. And we're going to join those date frame. Just using the date frame 1, join date frame 2 on column article ID, and it is an inner join. This is actually what we want. There is an article ID and IP address and article name. We're going to use some circle-like statement to deal with the data. First, what we're going to do is give it into a new date frame. So it behaves normal. And we are going to turn this date frame into a temporary table, like what we did in a traditional database. So the table name is actually the TBL underscore join. So we can write down some circle statement in Spark programs. So we can also write down a new circle statement that shows which article is the most popular one. So we can see we fetch the top 3. We can verify it in our dataset, like the third one is we go into our dataset. And first we are getting the article IDs, represent this article name. And we grab these article IDs from the whole log file and count, give it a count. It is 2,530. So they're the same. So we are doing the right thing. So this is actually the two method. One is based on RDD and based on date frame. The RDDs will be replaced by date frame APIs. So we are going to pay more attention to the date frame. In this session, we are going to talk about how to optimize those programs. Because we are running on local environment, which means we only have a single instance. But usually when Spark platform using in production system, it will run in distributed system. And our dataset is quite small because it is just for demonstration and training. In real world use case, it will be very large. Let's take a look at those dataset. The dataset 1. Dataset 1 it is a log data. It will grow bigger and bigger. And maybe hundreds, thousands of terabyte or gigabyte. And those dataset 2 is a dictionary dataset. It will not grow that much. So it is a small dataset. We have those datasets joined. So if dataset 1 is big enough, it will distribute in different servers. So like this, there's 4 servers in your cluster. So it will be 1, 2, 3, 4. 4 parts made up those whole log file. And the small dataset 2 will small enough to fit in a single server. So when those files do a join, it will all cross the internet of the cluster. So because each line of code will compare to each line of the data in dataset 2. So it will be cost of the internet bandwidth. So what we're going to do is to distribute this small dataset into those servers. So that will save some cost. That is called broadcast the small dataset. So that's usually what we are going to do is that when you using the small set to join the big dataset, usually we will broadcast the small set into the servers where the big dataset located in. So that's an important optimization. So let's take a look at how to do it in our program. So we're going to use a method called broadcast, and it is from the PySpark circle functions. And we are going to broadcast a small dataset, which is at AC list. and join the big data set. Which will be the article ID, and it is an inner join. We should code the inner. So when the data set is big enough, you can see an obvious improvement of the performance. So that's one optimization method is called broadcast, when a small data set joined to a big data set. In the last part, let's do a quick demonstration on structured Spark streaming. Let's say you want to maintain a running word count of text data received from a data server listening on a TCP socket. So we use the nc command to generate some data into the 9999 port, and you are using the code to receive the data. So these are, because this is quite interesting, you can just to feel how does it works when doing the streaming program. So we see we can generate some data in the consoles. And for enter to send those data. So this is a one-line data, and we can see it's actually performing in another console. This is a PyCharm. It is IDE is for the Python on Spark. Oh, we can actually see the result. How many counts are there? We are not going to tell the detail of the Spark streaming in this class. We will cover those in the next one. Okay, you can see how it is going on, because we have RDDs and data frame, and the Spark streaming is also separated into RDD based and the data frame based. So this is the data frame based. We can actually see the result is in a table formed. It has columns with word and count. So this is a simple Spark streaming. We will cover it in our later courses. Okay, have a nice day.